Hi, this is the team the Dolphins, and let's talk about a molecule of aquatic origin that is alginate. The and your names are Carolina Felix, Eduardo González, Itzel Abigail, and Erika Hernandez.
As a small introduction, we have that alginate is the most abundant polysaccharide present in some brown algae. They compress up to 40% of its dry weight. Alginates are the structural components of the cell wall of algae, whose main function is to guide rigidity, elasticity, flexibility, and ability to bind water. The history about its discovery. The first studies related to the extraction of alginate from brown algae were carried out by the British chemist E.C. Stanford in 1883. Stanford, through the digestion producers of brown algae with sodium carbon, observed that gelatinous substance was formed, which he called algine, for behind of substance derived from algine. The alginates are extracted mainly by three species of brown algae. This include Laminaria hyperborea, Ascophyllum nadosum, and Macrocystis peripherea. Laminaria hyperborea has a common name, triangle and cube. It is located in the subcoastal zone of the North Atlantic Ocean. Ascophyllum nadosum, their common names are rock eagle or kelp. It is an algae from the North Atlantic Ocean. Macrocystis peripherea has a common name, the giant sargassum. It's a giant brown algae that inhabited the Pacific coast of North America from Baja California to Alaska, in South America, South Africa, and Australia and New Zealand.
About the physicochemical characteristics, we have to know that alginate comes from alginic acid, that is a biopolymer, a polysaccharide made of units of mannuronic and hyaluronic acid. In figure number 3, we can see their structures, and they are epimers or isomers, meaning that they have the same atoms but they have different configuration. And we can see that they have a functional hydroxyl and carboxyl groups. Alginic acid can have different distribution of the monomers. As we can see, they can have homopolymeric blocks, being G or N blocks, having only one type of their monomers, or it can also be heteropolymeric, having a G-M block. And lastly, alginate is the salt of alginic acid, where it has in their carboxylate group an ion such as sodium or calcium. The chain structure of alginate is linear, meaning that it has no branches as other polymers, and the bond of these molecules is glucosidic. In figure number 5, we can see that depending if the block is RM or G or GM block, the molecule has a different structure. And in figure number 6, we see sodium alginate, and like I said before, there is sodium in the carboxylate groups. The molecular weight varies in function of the chain length, but here we have that the monomers have a molecular weight of 194.14 grams per mole, and it's the same for both because, well, they are isomers. And the monomer of sodium alginate has a molecular weight of 216.12 grams per mole. And the weight of commercial alginate range from 33 to 400,000 grams per mole. The properties of alginate change with the composition and length of the chain, and we know that alginic acid is not really soluble in water, but alginate salts they are, and when they are in an aqueous solution, it has high viscosity, and this property increases with the pH. And also, this molecule can absorb a lot of water, helping to make a degellation. One of the main characteristics known about alginate is that it can form gels. This thanks to their interaction with some cations undergoing ionic gelation through the cross-linking process between different chains of the polymer, meaning that they get linked together like we can see in the picture. And this part is the eggshell model because it looks like one. It happens because of the chelation that takes place thanks to the structural features of the G blocks, that the G blocks are like triangles. So when they are linked together, it looks like an eggshell box. And that's why the G blocks are important for the gelation of alginate. And here we have the biosynthetic pathway of alginate. It is better known and understood in some bacteria. That's why in some places of the algae pathway we have question marks. But here we have it. First, we have the fructose 6-phosphate that comes from oxaloacetate from the tricarboxylic acid cycle. This molecule suffers an isomerization and becomes mannose 6-phosphate. Then again, another isomerization occurs and the position of the phosphate changes and it becomes mannose 1-phosphate. Then GDP mannose pyrophosphatase acts and with addition of GDP it becomes GDP mannose. Then there is a dehydrogenation and it becomes GDP mannuronic acid. And this is the molecule that will form the polymer, losing a molecule of GDP with the bonding between them having only mannuronic acid. And then the epimerization occurs, so we can also have hyaluronic acid units and the final form of the algal alginate. If we compare the pathway of algae and bacteria, we see that they are pretty similar, but the bacteria alginate has the reaction of acetylation, and that's the main difference between them.
The use of alginate in the food industry. Alginate has unique thickening, gelling, stabilizing, and film-forming properties that are highly valuable in the food industry. The thickening properties are commonly explored in jams, marmalades, and fruit sauce, give a higher viscosity that doesn't either individual component. The other use is for alginates in bakery creams and other cream with freeze-down stability and reduced separation of the soil and liquid components, synerases. And the film-forming properties of alginate can be used as sauce casing and for coating meat products. Use of alginate in medicine. Alginate dressing protects the wound from harmful bacteria, promotes growth in new skin, and promotes a healthy environment for the wound and stability blood flow in bleeding wounds. The medical alginates use a biological substrate and immobilizing cells of enzymes so as to allow further systems to be converted to penetrate the material. It is ideally used for regenerative medicine applications being one of the most abundant biosynthetic materials. In a study, it has been found that alginate oligosaccharide are capable of increasing the systolic blood pressure of the hypertensive rats. With that result, it was be found that alginate has significant effect of lower hypertension, which ideally can be applied to humans.
The extraction process is divided into phases to obtain sodium alginate. Phase 1 Primary treatment. First, the alginate occurs, They are xenauron to a size less than 1 centimeter in diameter. They are succulently shaped on the vibrating screen and portion of sand is separate. At this point, the solid is dried and broken up into small particles for the separation of the alginates. Phase 2. Extraction of sodium alginate is begins by reaction with hydrochloric acid. This allows the exchange of cation present, transforming the alginates of the solid matrix into alginic acid insoluble, which allows a more efficient recovery of them. This treatment is carried out with solution for 2 hours. The algae are be washed and filtered in order to remove the acid received from the excess ads. The washing liquids can be used to recover potassium since algae have a large amount of potassium in their structure. The solid residue is then separated and subject to maceration. The alginic acid obtained in the previous step is subjected to alkaline treatment to stabilize the extract of sodium alginate. Obtaining crude sodium alginate allows the alginate to be separated from the solid matrix by physical methods, filtration, centrifugation, decantation, etc. Since sodium alginate is soluble. Once the compound has been transformed into sodium alginate, it is necessary to dry the ice to facilitate their migration to the aqueous phase. As the product is diffuse, it is necessary to promote it by acting in three directions: large amounts of water, increasing the temperature, and stirring the dough. Subsequently, the separation of the solid mass is carried out of which a basket centrifuge is used, and at this point the sodium alginate is incorporated with various elements that receive acid and base attack and separate in the same phase as this alginate. This is what is called crude sodium alginate. As a control of this stage, the viscosity of the filter is determined for the maceration carried out figure and each time of the same. Phase 3. Purification. It consists of changing the compound's phase to eliminate the contaminants with the other phase. The subsequent recovery of the compound is therefore carried out under better conditions of purity. The alginate precipitation can be performed with 10% calcium chloride to moderate excess. The solid obtained calcium alginate is bleached and deodorized by washing. Calcium alginate is the first product of commercial interest obtained in purified form. From it, you can get the rest. The calcium alginate in the transformed into alginic acid by acidification. The alginic acid obtained is dried and dried in vacuum oven 50 until constant weight. This allows absorbed water to be removed. Finally, sodium alginate is obtained from the acidic solution of the alginic acid by alkalination with caustic soda. As this alginate is soluble in water, it is dried in vacuum oven 50 until constant weight. The commercial presentation and the price. We can find alginate in different presentations as we can see in the following image. The most common are power and yield. Sodium alginate is commonly used in the industry to obtain impression of teeth and additive salt dish for molecular use, additive in food. Other uses are taken for creams, detergent, textile print, inks, and a wide variety of products. The price we can find in the market in pesos mexicanos are 510 for a 1 kilogram sodium alginate powder for molecular cooking, 150 for 405 grams butyl alginate body casting, and 129 for 40 grams sodium negative power in food added.
In the social free, especially in Mexico, there is an important production of alginate with the giant sargassums due to its high content of this phycology and its abundance, which creates an investment opportunity in which there is a wide availability of untapped resource and also has a technological process to obtain alginates. And the ecological importance about alginate and the reduce of the alginate extraction process can be used as are fertilizers since the bacteria Gracillium baculum degrades the alginate to oligosaccharide during the composting process, and recent studies describe the economic potential of the production of bioethanol from algae, based on the fact that the raw material can be derived from the residues produced by the alginate industry, which is highly enriched in sugar such as mannitol and laminoran, in such a way so initial costs are drastically reduced.